Remind me what a combination is. When 12 equals 21. So 12 equals 21. For instance, handshaking. Me shaking your hand is the same as you shaking my hand. Putting people in a group. Say, you three get to work together today. That's a combination. What else? Picking people to play baseball. 7 of you get to play today. Or 9 or whatever. Okay? Permutations happen when order matters. So for permutations, 12 does not equal 21. A combination we did yesterday was taking books to school. If you have 6 books and 4 get to go to school, that's a permutation. Or a combination, sorry. A permutation is things in order. Numbers are permutations because the number 12 is not the same as the number 21. Lining up, books on a shelf, all of those are permutations. With, what is replacement? What does that mean? So if you're drawing numbers from a bag and you're pulling them out in order, so you pull out a 1 and then you pull out a 7 and then you pull out a 5, 175 is different from 156. If you pull out a number and you write it down and you stick it back in the bag, that's called replacement. And a permutation with replacement still has 12 does not equal 21, but now 22 exists. So if you pull out a number, write it down, stick it back in the bag, and then reach out another number, you're allowed to use duplicates of the same number. Okay? So on yesterday's assignment, how far did we make it? So I'm not going to do the calculations. We'll just talk about whether it's a permutation or a combination. So number 7. A bookshelf has 3 math, 3 science, 3 social studies books. If all of the books are different, how many ways can they be arranged on the shelf? Combination or permutation? Permutation, why? Order matters. Right? If you go to the library and change the books around, the librarian's not going to be happy. Okay? So there are 9 books. How many are we arranging? 9. So we're going to have 9 spaces with or without replacement. Without, because book 1 cannot be in one spot and in another spot. So how many options for the first spot? 9 times, how many for the second spot? 8. Now I'm lazy. We're going to go all the way down to 2 times 1, right? There's another way to calculate permutations without replacement. Actually, that would work. In this case, 9 factorial will work because we went all the way to 1. It's in the probability. Go to math. The 4th column says probability. Or you could also do 9p9 because we're using all of them. And just as review, 9p9 is equivalent to 9p8. It's in the probability. So math, it's NPR. So push 9, NPR. On your calculator, it'll look like this. 9, NPR, 9. Okay, and if you missed yesterday, I highly recommend the video. Really, you should watch it. It will definitely help. Okay, so I don't know what that is. You guys figure it out. All right, number 8. 10 students wish to go to lunch. How many ways can we line up 5 of them? Ooh, that's mean. Combination or permutation? Does order matter? Line up for lunch. If things are in a line, order matters. Because if you're really hungry, you want to be the first person. You should just be happy to be in the line because 5 kids didn't make it. But, so it's a permutation. So we could do, oh wait, with or without replacement? Without, because no person can be in 2 places. So we could do 10p 5, or how many options are there for the first space in line? 10 times, well, the first spot could be any one of the 10 people. The second spot would be one of the remaining 9 kids. Times 8 times 7 times 6. Will the factorial button work there? No, because it doesn't go all the way to 0. You could do 10 factorial divided by 5 factorial, but that's exactly what this does. So I wouldn't. All right, number 9. Utah license plates have 6 digits, except for vanity plates. Each digit may be either a number or a letter. How many different variations of plates are there? Combination or permutation? Permutation because order matters. License plate 12 is not the same as license plate 21. Okay? Does the license plate AA exist? Yes. You are allowed to duplicate letters on license plate. In fact, my Rock Awesome minivan has 3 4s. Go figure. They're all in a row, too. All right, so 6 places. That's 5. This is with replacement. Can I use the NPR button? No. NPR only works without replacement. How many options are there for the first digit? 36. 26 plus 10. Right? Yeah, 0 counts. So 0 through 9 is 10. There are 10 digits there. So 36. How many for the second place? 36 again. 26 letters, 10 numbers. Yeah. So it's going to be 36 over and over and over, which makes 36 to the 6. Now, in Utah, when I was young, it was number, 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 letter, letter, letter. Now it's changed. Now it's letter, number, 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 letter, letter, or something like that. Yeah, they ran out. They ran out of a specific sort of possibility, so they scrambled the numbers and letters. But this right here, that big number, is every single 6-digit possibility. In Utah, we're working on subgroups at the moment. We finished all of the letter, number, 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 letter, 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 so we moved to something else. We're not going to run out, though. That's a pretty big number, right? 2 trillion. Great. Number 10. A baseball team has 15 players on its roster. How many ways are there to pick 9 starters? Combination or permutation? It depends. Are we putting these people in positions, or are we just allowing them to play? So we're going to say 9 of you are going to start. Right. So you could read this either way, but my recommendation is, unless I specifically tell you there are positions, I mean combination. Okay? So in this case, it doesn't say starting positions. It just says 9 of you get to play, which means it's a combination. So for a combination, you use the C button. How would we calculate this? 15, choose 9. And if we look up at our paper, it's not quite big enough. There are not 15 rows, so we have to use the button. 15, choose 9. Okay, number 11. A baseball team has 15 players. How many ways can you create a 9-person batting order? Is that the same? No. Well, it certainly doesn't have replacement, but now does 12 equal 21? If I'm batting first, that's different than me batting second. So now it's a permutation, with or without replacement. Without, nobody can bat twice in the same order, in the same batting order. So how do we calculate 11? 15 P9, or I could do 15 times 14 times 13 and fill out 9 spots, but I wouldn't recommend that. Number 12. A local bank branch has 6 tellers. If 3 tellers are needed to staff the bank each day, how many ways can the bank staff its branch on any given day? Combination or permutation? Why combination? As far as we know, they're equal. All we know is that they're tellers. Now if I said, you get booth 1, you get booth 2, and you get booth 3, that turns it into a permutation. Okay, but the question just says 3 get to work. It doesn't give them specific jobs. It doesn't tell, it doesn't say morning, midday, afternoon, or something like that. So how do we calculate this one? 6 choose 3. Let's use the paper on the wall to figure that out. Go down to row 6. 6 choose 3 would be 20. Remember, we skipped the 1. The 1 is 6 choose 0. How many ways are there to pick no tellers? 1. You make them all stay home. So the 6 would be 6 choose 1. The 15 is 6 choose 2. And the 20 is 6 choose 3. Just as a reminder, 11 choose 3 is equal to what other combination? You don't even need to look at the poster. No. You can't do 3 choose 11. You have 3 books. How many ways are there to put 11 of them in a backpack? You can't. There are only 3 books. 11 choose 8. How do you know that? If 3 people get to go to work, 8 people stayed home. So if 8 people go to work, 3 people stayed home, and the combinations are the same, and you can see that on the poster. 8 choose 3 is, 11 choose 3. 11 choose 3, 165. 11 choose 8 is also 165. So if you're calculating combinations, the large numbers are in the middle. The more books you start putting in the bag, you start running out of room. How many ways are there to put all of the books in the bag? 1 way. You put them all in, which is equivalent to leaving them all out. How many ways are there to put no books in a bag? 1. You don't put them in. Yeah. What if I did something like 11 choose 12? What's the answer? 0. If you have 11 books, how many ways are there to put 12 of them in a bag? None. It just can't be done. It's impossible. Okay. Number 13. Ping pong balls are labeled 1 through 11. How many ways can I reach in and pull out 6 of them? Combination or permutation? Is there an order? Does it say I'm pulling them out one at a time? No. You reach in, grab 6, pull them out, which means combination. So how would you calculate it? 11 choose 6. Look at the poster. 11 choose 6 would be 462, which is equivalent to 11 choose 5. Because if you pick 6, 5 remain in the bag. There are just as many ways to pick 6 as there are to pick 5. Okay? 5 city council members are being considered to chair the 7 committees in the city. How many different ways could the chair people be selected, assuming that a person may chair more than 1 committee? Permutation with. Why? Same person can do more than 1 thing. There's another reason why. Is it possible to fill 7 positions with 5 people if you use a combination? No. Is it possible to fill 7 positions with 5 people if you use a permutation without replacement? No. So whenever your R value is bigger than your N value, it has to be a permutation with replacement. So there are 7 slots. How many for the first one? 5. 5 for all the others. 5 to the 7th. All right. Are we on the last one yet? Yeah, it's N to the R. This is the number of people. This is the number of positions. Okay, this is the number of marbles in the bag. this is the number that you're picking. And the only way for the number picked to be bigger than the number in the bag is if you put them back in the bag after every draw. That's basically what it's saying. Okay, I love this one. If there are 6 people in a room, how many ways can they line up if Jim insists standing behind his wife? First of all, combination or permutation. Why permutation? 12 and 21 are 2 different lineups. Okay? So let's write out those 6 places. With or without replacement? Without, definitely. No person can stand in 2 places at the same time. Unless you're Fezzik. Then he occupies 3 places. Okay. How many options for spot number 1? 5. Can the first one be Jim? No. Why not? He has to stand behind his wife, so he cannot be in the first spot. So that leaves 5 people. All right, so 5 there. What about the next spot? One way. Doesn't matter. It can't be 6 because one's already lined up, right? So why are we saying 5? If it could be Jim. Does Jim get to pick where he stands? No. So what does this depend on? Is that 5 his wife? We don't know yet. Let's assume it is. So if the first person to line up, so there are 5 choices, but if the first person to line up is Jim's wife, then the next slot would be 1. Right? If this is the wife, there's a 1 in 5 chance that this is the wife. If it is the wife, then this is Jim. In which case, it's a 1. We're not sure about that, but let's just count this up and see what happens. Okay, what about the next slot? There are 4 people left. And that, multiply those together and you get 120. There are 120 ways for Jim to be in the second spot. A better way to say that is, there are 120 ways for Jim's wife to be first. Is that the only situation? No. What else could happen? How many options for the first position? 5 again. Okay. How many options for the second position? 4, because Jim can't be there, right? If this is not Jim's wife, then that is not Jim. So this could be 4. If that happens to be Jim's wife, then Jim would be next, so that would be 1, 3, 2, 1, for another total of 120. So there are 120 ways for the wife to be first, 120 ways for the wife to be second. Close. So what else could happen? We could have a 1 there, or we could have a 1 there, or we could have a 1 there. So that's 120 times 5. Because Jim can only be in 5 places. He can be second through 5th. He can't be first. And each one of those has a chance of, or a total of 120. So you add those all together. Okay. Today's worksheet, probability. Today we will be using our knowledge of combinations and permutations to calculate probabilities. So probabilities are the chance of something happening. If I have an 8-sided dice, what are the chances that I roll a 6? 1 in 8. So that could be expressed as 1 over 8. It could be expressed as 12.5%, or it could be expressed as 0.125. Those are all probabilities. And probabilities are the chance of a particular event divided by the total number of events. How many ways are there for a 6 to happen? 1. How many different options are there? 8. What are the chances of rolling that same dice and rolling an even number? 4 out of 8, which simplifies down to 1/2. What are the chances the number is a 5 or a 6? 2 out of 8, which simplifies to be 1/4. Okay? Hopefully that makes sense. Let's start with something simple. We have a bag with 2 red, 3 white, and 5 green golf balls. Let's determine the probability. What are the chances of drawing a red? 2 out of 10, which simplifies to be 1/5. Now, this is different from odds. Probability compares the chance of an event to all of the events. Odds compare the chance of an event compared to every remaining event. So probability is the chance of something happening divided by the total. Odds calculate the chance of something happening divided by what's left. So in this case, it would be a red divided by not red. But we're not going to do odds. But if you hear odds, that does not mean probability. Okay, well, it doesn't mean, well, I guess technically it's not probability, it's called odds. So the probability is 2/10. The odds are 2 to 8. Because you compare what you're looking at with what's left. Okay, but we're not going to do odds in here. Just so you know, odds are a little bit more complicated. Okay, drawing a white ball. 3/10. 2 plus 3 plus 5 is 10. Yeah, there are 10 in the bag. Drawing a green. 5 out of 10, which is 1/2. Drawing a red or a green. 7/10. Everybody follow? If it's red, you win. If it's green, you win. 7 out of 10. Drawing a white or a green. 8 out of 10, which is 4/5. What if I said a white and a green? Yeah, what's the chance of pulling a ball out and you get a white and a green? Think about it. If you pull one ball out of the bag, what are the chances it's white and green? None. So in general, when you do probabilities, ors have bigger probabilities than ands. Sometimes ands don't even exist. Okay, or you end up adding, and you usually end up multiplying, but it gets really confusing. Okay, red or white. 1/2. Not drawing a red. How'd you get that? You have a 2 in 10 chance of drawing a red, so you have an 8 in 10 chance of not drawing a red. What's an equivalent of saying not red? White or green. So not red is equivalent to white or green. Okay, not drawing a white. 7 out of 10. Not drawing a green. 1/2. So drawing a green and not drawing a green are the same. Okay? All right. We're going to play lottery. Thing about the lottery is, I had a statistics teacher who used to always say in college, the lottery is a tax on stupid people. So that's my wisdom for the day. Don't play the lottery. Okay. To calculate each probability, suppose a certain lottery involves selecting a 3-digit number where each digit could be any of the numbers 1 through 5. Is each lottery ticket a combination or a permutation? Is 12 the same as 21? No. Because all you're doing is picking a 3-digit number. If I pick 157, and you picked 751, do we have the same number? No, this is permutation. With or without replacement? Can you use the same number twice? Well, a 3-digit number where each digit could be any number 1 through 5 with replacement. Okay? So how many total tickets are there? Well, there are 5 digits. How many numbers could go in the first, or sorry, 3 digits. How many could go in the first slot? 5 times 5 times 5. So each one of these problems is going to be divided by 125. Okay, letter J. What is the probability that 321 is the winning number? There's only one of them. 1 out of 125. Letter K. What is the probability that none of the 3 winning numbers are the same? Oh, good. Here's one way to figure that out. How many numbers are there where all 3 digits are the same? 5. All 1s, all 2s, 3s, 4s, and 5s. There are 5 of those. Is that all that we need to throw out? We need to throw out the 112, the 113, the 114, the 115 because it has 2 1s. We also need to throw out 121, 131, 141, 151. Do we want to count those up? No. There are quite a few left. So let's figure it out this way. How many digits can go in the first spot? 5. How many can go in the second spot? 4, because whatever the first number is, we're not allowed to reuse it. Times 3. So really, all we did was switch from with replacement to without replacement. So you could also do 5P3, which is 60. So 60 over 125, and that's going to simplify to 12/25. So slightly less than half of them have no common digits. Slightly more than half of them have at least one common digit. Okay? What is the probability that the first number is a 5? Why 1/5? If we look at all the numbers, 1/5 of them start with a 1. 1/5 of them start with a 2. So 1/5 of them start with a 5. How would we do that? Using this. So, right. So the first number is a 5. So do I get to choose that number? No, I only have one choice. No. Once I move on to the second number, can I get any of the 5? Yeah. This number could be anything, and this number could also be anything for a total of 25. 25 out of 125 is 1/5. So that would also work. Okay? Letter M. What is the probability that the winning number contains at least 2 3s? Ooh. So you're saying there are 5 numbers that have 2 3s in them. What are they? Is that all of them? Well, let's do it this way. So we could write them out. 1 3 3, 2 3 3, 3 3 3, 4 3 3, 5 3 3. I could write them all out, but I don't want to. So here's what I'm going to do. How many ways are there to pick the first number? Well, it depends. If it's a 3, how many ways do I have to pick it? 1. So let's just assume it's not a 3. If it's not a 3, or no, let's say, well, it could be a 3. So let's say there are 5 choices. Okay? If that's not a 3, what is this? Has to be a 3. So how many ways are there to pick this number? 1. And this number would be 1. So this situation represents what? The last two numbers being 3. Is that the only possibility? No. Where else could they be? So you could have 1, 5, 1, or 1, 1, 5. So that's a total of 15. But close. You're on the right track, but you're going the wrong direction. We've overlooked something. This list matches that. Right? What would the second list look like? Does anybody see a problem? Oh, yeah. In the end, that would work. So this is 3, 1, 3, 3, 2, 3, 3, 3, 3. That's a problem. Why? I already counted this. So you could subtract 2 because there's one of them here and one of them here. Or we could change our calculations. How would we change this calculation to match? Change 5 to 4. Yeah, we came up with 3 lists of numbers. Each list had this number in it. So really, 511 is totally correct. The number 333 is in this list. This list cannot contain 333. So this is a 3, and this is anything but 3, and this would be a 3. Do we have to change this one? Because, well, let me write them out. 3, 4, 3, 3, 5, 3. Okay, and this list will be 3, 3, 1, 3, 3, 2, 3, 3, 3, 3, 3, 4, and 3, 3, 5. So there are 5 there, and 5 there, and 5 there. But this number got counted 3 times. It's in every list. So this list should not have 5 numbers. It should only have 4. And this list should only have 4 numbers. Because if that's a 3 and that's a 3, this cannot be a 3 because 333 is already in this list. Same with this one. 1, 1, 4. So there are 2 ways to do this because that happens a lot. Either you calculate it normally and you subtract off the duplicates, which is what Riley was saying. 15 minus 2 gives us a total of 13. Or, as you do the calculations, you eliminate the duplicates along the way. So if you do 5, 5, 5, how many versions of 3, 3, 3 are there? 3 of them, and how many can we keep? 1, so 2 have to go away. Or, you say there are 5 of these, which means there are 4 of those and 4 of those. And either way will work. But just know, sometimes you end up counting duplicate numbers and you have to subtract them off. Sometimes it's way easier to count the duplicates and then subtract them than it is to eliminate them. It just depends on the problem. Okay, letter N. What is the probability that all of the numbers are the same? What do you mean 5? There are 5 ways to have 3 duplicate digits. So 5 out of 125 is 1/25. And letter O, what is the probability that all of the numbers are less than 5? Let's think of it this way. How many digits are we including? In the original problem there are 5 numbers, right? If I throw out one of the numbers, would we expect 1/5 of all the numbers to go away? So would we expect there to be a probability of 4/5? Why not? But if I had 5 times 4 times 3 times 2 times 1, and I eliminate the 5, is that 1/5 of what's there? I'm just trying to confuse you. Let's look. Okay, let's do it this way. How many options are there for digit 1? 4, because the number 5 died. How many options for digit 2? 4. How many for the next one? So 4 times 4 is 16 times 4 is 64 out of 125. Is that bigger or smaller than 4/5? Much smaller. In fact, that's just barely over 1/2. Because there's still 125 tickets, but the one where the winning number does not have a 5 in it. So sometimes funny things happen. You would think that if you went and burned all of the tickets that had 5s on them, you would get rid of 1/5 of the tickets, because that's 1 in 5 numbers, but it doesn't work that way. You actually get rid of nearly half of the tickets. Nearly half of the tickets have a 5. Right, if you eliminated the 4, you'd cut it in just about in half again. Okay. So, sometimes working combinations and permutations using the formulas is way harder than actually writing out the positions. So, turn the page. For instance, flipping coins. If you flip 2 coins, how many possibilities of results are there? Let's write them out. Heads, heads. If I flip 2 coins and look at them, heads, heads. You could also get heads, tails. Is tails, heads the same thing? This is where it gets hard. Okay, and it's going to get even worse when we start doing poker. But whenever you flip coins, kind of. Right. When you flip coins, never think of them as both quarters, because that will confuse you. Whenever you flip coins or roll dice, always make the coins different, a quarter and a nickel. Or if you roll dice, a red dice, a green dice, a blue dice, a yellow dice. Okay? That will help you keep things separately. Is heads, tails different than tails, heads? Yes, because one's a quarter and one's something else. Okay? So the other option would be tails, tails. So this is actually a permutation with replacement. But don't think of it that way. There are only 4 possibilities. So just write them down. Okay? Coin flipping is confusing. Dice rolling is confusing because it seems like a combination, but it's actually a permutation. All right? So I have given you detailed explanations on each of the answers. Go through and do your calculations before you look at the answers. And then I'll answer any questions you have tomorrow. Okay? All right. Get to work. Good luck.